Hi everybody, we're going to be talking about file I/O today, and hopefully I can do it all in one go and it's going to make sense to you, many of you. This is going to be very similar to printf statements, which we've been doing for a while, and I just thought I'd point out the fact before we get going, there is a slew of extra slides at the very, very end, but they're not going to be covered for the exam, and they're not really what you're expected to be able to understand for this course because they're the C++ versions of all these files. There's cout and cin like we did before, but there's specific functions for file streams so that you can read in a file stream and that you can output a file stream. We're not going to be covering it in this class. We'll cover it a little bit in 2400. But just in case you're interested, it's there. So, normally when we're printing out information, we put it out to the console. And maybe just the nature of how we go about teaching this kind of class, people start thinking that that's the only real game in town. That's when we do with functions, when we do anything at all, everything goes to the console. That's not actually true. That's only one very, very small part of what we do. So we could be doing a graphics, a painting program like I showed you last class, or last lecture, I should say, and maybe that painting program draws a square. It doesn't need to put things to the console window and print out text. It can do other things. Or we can output things to a file, and that's what we're going to be talking about today. So, normally with the console window, I have my program, and it's going to send information to the terminal window so you can see what's going on. And this is where our I/O functions, our input and output functions, come in handy. This is like printf and scanf. So we have some built-in ones, but and most of them have already been looked at. But let's have a look at some of the other escape characters that we're going to encounter. So we've already talked about the fact that new line /n it's a carriage return. It makes a brand new line. If I leave a space, then it's the space bar. /v is actually a vertical tab. I've never once used a vertical tab, but /t is our normal tab. If I press the tab key, that's what I would get. Now, the normally when we're dealing with input streams, we would oftentimes ignore the preceding spaces. That's especially true for cin and cout, but most of the time when we're reading in things like scanf, preceding spaces are ignored and then we just get to the heart of things, whatever the person types in. So let's have a look quickly at one of these things. So we can play around with what C can actually do with a printf statement. For example, I can actually do this thing right here, and that's going to give me some really crazy stuff. So I'm going to output a floating point number and I have to look into, and so let me point out, I'm not going to be asking or quizzing you guys on exams about the minutia of how to use certain printf statements. This is one of those cases where when you encounter it or when you need it at some point in time, you will learn it, but you don't try and keep all of that stuff in your head. There's pages upon pages of documentation about what flags to use. So if you don't believe me, let me just quickly, hopefully, here is c++.com and my references to printf. And so here would be an example of me doing a printf for a bunch of characters. Fine. Here's me doing a printf or a decimal value, an integer, long and a long integer. Um, Here I'm going to be proceeding with 10 blanks in the front. Here I'm going to be proceeding with a whole bunch of zeros in the front. Why? Because it's an option. If I want to do hexadecimal, I can do that. If I want to do octal, because you know how useful that is, I can do that. There are all sorts of crazy things that I can do here. Here's what I just showed you. I'm going to put a 4.2 in front of my f, so I'm going to return some kind of floating point number. There's a 4.2, but let's have a quick look at what this is actually going to do. This is 3.1416, and you'll notice we have this weird part here. That's good. We're going to have a look at this and what the capital E is going to be. Notice the same value is being introduced for all three. So let's have a quick gander down here. Here is 3.14, the first value, with this 4.2 thing here. And here is my exponent, my lowercase exponent. Here is my uppercase exponent version of how I would write that. But this 3.14, this, let's have a look at what the heck that actually means, because it should be representing the number of spaces that I'm going to be taking up and what I'm going to be doing with it. So I could go, if I wanted to look at particular parameters here, I could see things like the amount of precision that I have. And if I put in a particular number, so if you want to follow along, I can not specify a particular string format. So I can actually change I can change the amount of text I'm going to be showing at any time. It might be better shown with one of these other later examples. So here is, actually, it was a previous example. Here is, I'm going to put 10 preceding, or I'm going to make sure that there is exactly 10 characters in total, whether it includes that whatever the value is or not. So D is 1977. I'm going to output 10 characters. If I need to add extra characters in there, I'm going to be adding zeros. That's what this thing right here does. If I leave off that 0 in the front, I get this. I get put spaces in front. All sorts of fun stuff. This should be, there is exactly 4 characters here. If you look at, but that should, 4 characters, 2 after the decimal. Okay. This is one of those things I keep on having to relearn it every single time. I'm going to show you, and as I said, we're not going to be looking deeply into this, but let's run this one. So 8.2f 10.34156 something like that. So I'm going to throw this in here and just to see what happens. So printf, and then I'm going to do percent 2.5, let's say, and then I am going to put in the number 10.234567. Let me double check if that's the value I was supposed to be looking for. 8 and 2. Okay, that wasn't the number at all. And I need an F at the end here. Okay. Put a semicolon in here. Compile it. Let's see what I get. So the first line we'll see all my code in action, but all right. You can ignore this gobbledygook at the end. Notice I have a whole bunch of spaces which I didn't add. Then it was a 10.23 and then a bunch of zeros afterwards. Wait, let me look at this again. If I have 8 characters in total that I'm supporting, but after the decimal point I would only have 2, that would mean everything down after this would be rounded. And since this is for 5 characters, I would expect an additional 3 characters on the front to make it 8. And let's have a quick look at this again. I have presumably 3 characters on the front, then a 10, and then I have my 2 decimal places. I have my level of precision at the end is 2. That's what this is what this value is actually doing. If I went back to this, I'm going to be outputting 4 characters in total with a precision of 2 at the end. 1, 4, and there's a grand total of 4 characters. 3, 1.14. Sorry about that. So I could play with a whole lot of these things, but you can just look up the references. You do not need to put all of them on your cheat sheet. I'm not going to be asking how to make sure you round off a floating point number. This is one of those cases of when you need it, you look it up, but otherwise leave it alone. So I would also like to point out that printf, sprintf, not sprint, and there should be an F. It automatically auto-corrected on me here. So let me put that F in there. F. And fprintf all do about the same thing. They're very, very, very similar. So printf prints to the screen. We've already been using this. sprintf outputs all of that text, all those characters, to a character array. It's putting it into a string. And then fprintf puts all those characters into a file. So here we go. Here's printf. It takes, so I'm going to say hello, whoever, whatever the person's name with that particular ID, new line. So with the student name and the student ID, that's what's going to go into S and go into I. And at the end of the day, it's going to print out the number of characters that printf puts out. sprintf will do the same thing. It'll return the number of characters that are being output or that are going to be put into this buffer right here. So here's the same thing. Joe in 1234 is going to go into this particular string. This particular string is going to be stored in a destination buffer right here. I don't know if you can see the cursor or not. And then fprintf is going to be very similar, but instead of putting it into an array, I'm going to put it into a file. So here is an open file. We'll look at that in a second. I have my string that's going to be going into the file. So here is my file. That string is going to go into the file, but all the syntax looks extremely similar to what we had before. So we can do all sorts of weird things. So in this case, this will be left aligned. That's what the dash means. Then the plus will say you will add a plus or a minus no matter what, not just for negative values, but if it's a positive value, put a plus in there. And then I will have 5 number precision on this number, and then I'm going to output the value 10. So I would assume to be 3 spaces at the front, then a value is 10. Oh, I could also be left aligned to that. But these are things that there are a lot of nuances that you can have. Just quick reminder, SCANF, printf, fprintf, all of these functions, there is a safe or secure. I still could not track down what that underscore s is for. Is it safe or secure? One or the other. But all of them now require this underscore s. Now you can turn off those warnings. A lot of students do that. I'm okay with that. But I'm wanting to get myself into the habit of using the safe or the secure version of all of these function calls, just because there's a safe version for a reason. So we're going to look at SCANF in a second. Notice what SCANF does. It takes in some kind of character, a constant character string, and then it takes in a bunch of parameters afterwards. And the number of parameters is sort of open, or it is open. So you're going to get the information from the console. You can have multiple different variables going in. I normally, as a sort of, I force myself to only ever write one value in scanf at a time. I find it just leads to confusion if you try and take in multiple variables at a time or multiple things at a time. And you'll also notice scanf is going to be, when we were using scanf all these other times, we needed pointers. Why? Because we need to directly modify some particular value. And so I will have things like which we've seen why we now have that ampersand in there before, because of pointers. SCANF does one special thing though. It only works on white spaces. It stops when it hits a white space. So that might seem wonderful, but if I'm taking a comma separated value file, which we'll talk about in a bit, then scanf doesn't work. If it's all separated by tildes, it won't work. It only will separate things based off of some kind of white space, a tab, a space. And if I'm separating my fields, like if I'm reading in a file, field by field, so each field is separated by tabs. Well, if there's a space in between two of my words, it's going to go. The scanf is going to stop as well, not just when I hit a tab. So there's a bunch of other workarounds. So here I am. I'm going to take in a string. I'm going to put it into a particular name and an ID, and I'm pretty sure I'm going to need this. So with or without that, I'm going to put that in there. And scanf, what you'd expect to do at the end of the day is it should return something, so I know that it was successful. What would be a bad example of scanf would be I'm not allowed to put in anything other than the fields I'm filling in. So I can't put something called name or carriage return or anything like that. I can only take in, actually I might be able to take a carriage return, but I'm only able to take in particular variables, and white spaces are effectively ignored. So it will take in some student name, student ID, but if I put the word name in there, it's going to give me a syntax error. It's going to not compile. And here's SCANF, and it's a I don't know example, and it's an I don't know example because I don't know if I flip them around. Notice that what the fields have. If I flip the ID and the name, will it still work? I'm pretty sure it won't, but I'm not 100% sure. There's a lot. If I flip around a character or an integer, though, it certainly will work, and I'll get weird results. Okay, all of this to lead into file input and output, and that just boils down to three major facts or three major steps. For any given file, we open the file, either for reading, writing, or for both. Then we access the file, we either read or write or both the actual file. So we open it up, then we do things with the file, and then we close the file. That's our general approach in all of our cases. And you'll please bear with me with the ugly syntax. We'll actually go over it a lot more soon in a live example. But and this A7 is also no longer. It's I do believe it's A10. But we'll clarify A10 steps. So we're going to look at printf. We're going to look at sprintf. We've already looked at many of these things, but we'll look at fprintf in a lot more detail. And then we'll figure out how to parse text, and then we'll articulate how we can have relative and absolute paths as well. So we're not going to be doing with file streams directly, at least. What we're going to be doing is we're going to make a brand new. This is a struct called a file. It's a file struct. We're going to make a pointer to a file struct, and then we're going to call open. Now, there's also a safe version of open, which I used. That's fopen_s. It will take in the file name, but fopen will take in the file name, and it will also take in what kind of mode the file is being read with. So that mode can be anything from, it can be a bunch of different things, but normally for us it's going to be R for read and W for write. I know, crazy. So I will literally put the quote R in this right over here, right where mode is. And I need to make sure I check is at the end of the day, is the file equal to null or not? If it's equal to null, it means something terrible happened. Not terrible, but for example, if the file's in the wrong location, I think it's in this directory, it's actually not, or I typed in the wrong file name. If I cannot open the file, then my file will be equal to null, and then if I try to use it, a whole bunch of bad things might happen, especially if I'm trying to read from the file. And then I can use fgetS or scanf or whatever the case is to pull things out from the file. And then, so after you read all the characters, you can get the next. After you read a certain number of characters, you get the next character. Now, this is a stream. The reason I want to point out this whole idea of a file stream is it means much like a stream, like a river. Once I'm not actually just staying in the same place. If I'm swimming in a lake and I'm in the water around me is staying around me for the most part. If I'm in a stream, the water's constantly moving past me. It's a sort of a constant flow. With a file stream, every time I ask for information, I get the next bit of information. I don't get the same information. If I say, give me a line of text, it will get me the next line of text each time. So if I call fgetS 4 times, I will get 4 different lines of text. I do not get the same result each time because it's a stream. It's not just picking up one, it's not just pointing at one location and giving me the same consistent result. That's the difference between what we would normally do, right? Most of the time, if I had a C string and I was trying to figure out, if I called, let me see, printf, and I use that C string, I'm not going to change the C string every time I call printf. It doesn't, I could just keep on reusing it and get the same results. Not the same with the file stream. It changes each and every time I use it. It will get the next line, the next character. So we're going to look at a bunch, opening a file with a file loading example, and just let me see if I can point out some other things. Before we get going, I want to look at absolute and relative path. So if you have not seen this before, this might take a little bit of getting used to. A relative path is normally a case where I currently am, much like the relative path from wherever you are now. If we were in the classroom, I would use this as an example. So the relative path from our classroom to to the Israeli theater, right? There is a path, and it's based off of where you started. Versus if I said, "Tell me where the Israeli theater is," without knowing where the person starts, what do I tell them? Well, I have to tell them that it's on the planet Earth, theoretically, right? But I also have to tell them that it's in the city of Ottawa, it's at Carleton University. But even if it's if I just started with Carleton University, I have to give the absolute coordinates of that building relative just within within Carleton University. It's not relative to where I am. It is not go 3 steps forward. It is across. It is at this particular building, right? The absolute file path says that it doesn't matter where I start from, where I'm calling this function from. That absolute file path is it's always going to work. Of course, if somebody changes their directory structure, so for example, if I'm installing a game on other people's computers, I have no idea where they put the game or where they put all the media that they were going to use. And so absolute file paths have problems as well. For relative file paths, it is where I currently am and away from that. So the dots, if you didn't know what those are doing, that's going to go up one directory, that's going to go up one directory again, and then my text.txt is in this other directory. So this is whatever directory I currently am in, go up 2 directories, and then I'm looking for my text.txt in that directory. For the most part, we're not going to be dealing with either of those. I'm going to put my text.txt smack dab in where all my other code is, but I might need dots to go up and down certain directories. So relative file path is based off of where the code is being executed, how do I find the text, versus absolute path is the text file is at this location, irrespective of where I'm starting from. Okay. So if I have a C colon slash slash, this is an absolute file path. That's sort of the dead giveaway that you're in an absolute file path. And I would also like to point out, for writing a file, we have another little weird quirk. We're going to only be looking at reading files. But if I'm writing a file, if I put a W in the quotes, it will erase whatever file was there with that name. So if I already have a file there, let's say it's log information, like a log file, I run my program again, it will wipe out my original log file without any warnings whatsoever. There are some flags that you can do to keep it around, but that is a valid concern whenever you're writing to a file. If that file already exists there, it gets wiped out. Now, there are ways to merge files, but if I'm writing with a W, that's what happens. And if I'm reading in from a file, so if I'm reading in from a file, that file has to exist for me to do anything at all. So if I'm writing to a file, I'll make a brand new file if one doesn't already exist. Reading in from a file, if it doesn't exist, I'll get null for my file pointer, and then all bets are off from what I do. So let's have a quick look at this. And let me point out this. Whatever I do, when I go to open my file, I could have it equal to, the file pointer could be equal to null. So I better make sure I have some kind of if statement to make sure that it opened correctly. And otherwise, maybe have some kind of output message saying, oh, the file does not exist, or something like that. And then at the end, we'll actually close our file. But I'll show you fclose in action. So all right, let's comment this line out, because that's not over. I'll actually just get rid of it. I'm going to read in, I have 2 different files here. I have CSV demo and CSV demo.txt. If you want, I can actually open up what the CSV demo CPP CSV looks like. It looks like this. Now that may not be overly surprising, but so this is just a text file with a whole bunch of fields, and in between the fields, I'm putting a comma. That's one of them. The other one is the same fields, but in between each of these fields, I have a tab. So this is what's called a tab delimited file. The other one's a comma delimited file. And if you didn't know where I'm using this from, let's hopefully have something. CSV demo. Here is what it would look like in Excel, right? This is the kind of thing people deal with all the time when it comes to spreadsheets. And you need some way of, if I need to some way of saving a spreadsheet somewhere else in a text file, for example, we need some kind of format. And one of the two classic formats is .text or .csv. .csv for comma separated value, and .txt normally is for tab delimited text files, and we'll look at those in a bit. Okay. So here I am opening my file. This is the classic old way of opening a file. Fopen. Here's the name of the file I'm going to open. Notice I'm using the it's not neither absolute nor relative because it's in the directory where all my C files are, and I am going to read the file. Here is fopen _s. It will take in I pass in a pointer to my file, so a pointer to a pointer, so that it can modify this. It can modify my file. I pass in the file name, and I pass in what mode I'm doing. In this case, I'm reading. If I was writing, it would be just this for writing. Okay, so I'm going to read in a CSV file. Let's change this up. Let's read in the tab file first. Okay, and I'm going to make some random buffer of 100 characters, and I have this number of characters thing just for safety's sake. All right, and I'm going to set them all to 0 just to see if that works, but actually I don't need that. I was testing something out. Okay. Now, there are two different ways I could deal with this, and this big long way is going to be the way we have to do it eventually, right here. Otherwise, but let's try the easier way first. The easier way is I'm just going to keep on calling SCANF over and over and over again until finally until I run out. And I wanted to be a little bit paranoid, so I have this total count value, and total count is going to keep on increasing every single time I do this loop. So here's a do while loop. I'm going to get whatever number of characters from the file, the next word or the next set of characters from the file. They're separated by spaces. So what I would expect this thing to do, if I go back to my text file here, it would be test. The next time I call this, I get example. Next time I call it, I get to. Next time, show, CSV, the same approach, right? It just keeps on going. All right. And I'm going to put all of these values into my buffer. So I'm reading from my file, putting it into this buffer. It's going to be 100. It'll take 100 characters. That's what the _s makes me do. And I also want to have, if I hover over this, oh, this should be an integer. Okay, so this is the number of characters I'm going to read in. Okay, great. So if the number of characters is greater than 0, I know I have something fair. Now, I'm not sure if I actually had to test this out. Number of characters, if it's not a valid number of characters I'm reading in, I think it actually is returning -1, not 0. That led to a whole bunch of fun on my end. So here we go. I'm going to, instead of having this 0 at the front, we've already looked at that, I'm going to make sure that each one of these outputs 10 characters wide, and well, I could even do 15. What the heck? All right. So I'm going to read in each of these words, each of these tokens, each of these fields, one after the other. Then I'm just going to output it just so I can see it in action. And I'm going to make sure that my total count is never over 30, just in case I have some kind of weird infinite loop. That's just me being paranoid. And I want to make, why is that? Could be 0. Okay, well, fine. It could be 0. Oh, yeah, it could be 0. Let me move that. If my file was never opened, I don't want to close it. There you go. Let's compile. Let's see what happens. Do I have an infinite loop? I may have an infinite loop. Let's find out. So I've opened my file. I do this. I'm going to get a particular character. I said I was going to print out that character. Let's see what happens here. I want to see what's going to go on here. So I'm going to read in the text file and 100 characters. Okay, let's find out. There's something. Okay, there you go. I'm in the right place. I'm going to go down. I'm going to get a number of characters. It's going to be the word test. That's the first word. I'm going to output test to the screen. Oh, and that was what my problem is. Something wonky happened there. So let's close it. And instead of, I'm outputting the number buffer, a buffer, I had a 10 here, so we can just get rid of that. Or I could just say, no, I'm just going to output the string. Make my life easier. Let's see, boom. All right. Test example to show CSV the same approach for all tab delimited files too. All right, we can run it one more time just with the, I'm going to use that new format that I just got rid of, but let's see what in action. I'm going to put a 10 here. That's going to be, I'm going to output 10 characters each and every time. Whether it requires 10 characters or not, and we'll see it in action. All right, I'm going to get rid of that breakpoint. And here we go. Test example 2 shows CSV. The same approach works for tab delimited files too. Exclamation, exclamation point. Notice CSV, I have a bunch of spaces in front of CSV. I have far fewer spaces in front of approach. Why? Because approach is longer. It's closer to 10 characters. Each one of these things is exactly from here to here is 10 characters. From here to here is 10 characters. Same with this right here. And that's the reason why it has this sort of funny look to it, but you might actually want that funny look. So this is me reading in a tab delimited file, but you might also notice, let's see if I have this here. Test example 2, okay, they're all one word each, that's fine. But if I change that and made them, had 2 words within that one tab field, so like hello world, 2 different words, 1 field, or 1 cell, I should say. If I had that particular, if I had something with a space, SCANF is actually going to think of that as 2 different tokens, 2 different words, rather than trying to lump them together. I couldn't have a space. The spaces would throw off my algorithm. So maybe I don't want tabs, or maybe I want tabs and I don't want to be just using SCANF, because SCANF will only get the next thing separated by white space. It will not worry what kind of white space I deal with. It could be a character return, it could be a tab, it could be a space. And it won't even deal with commas at all. So if I go to my CSV file, this is going to be considered one giant string. Every single one of those commas don't break anything. But what I want is same as being a field, approach as being a field, works as being a field, for being a field. Okay, so let's go back to our code here, and instead of all of this, I'm going to comment it out again. And here we go. And instead of the text version of this, I'm going to use the CSV version just to see it in action. All right. So what am I going to be doing here? I'm opening my file as usual. I'm getting some kind of total count, although I don't need it this time. I'm going to have the start of the line each time because fgetS, I said I would actually have to show you what this looks like in action. FgetS will take in a full line of text. Irrespective of what's on that line, until I get a carriage return, it will keep on collecting information. So fgetS will take, here's the buffer all the information is going to, here's the maximum number of characters that is going to go into that buffer because it's 100 characters. And I actually should make it 99. Why? Because if I make it 100, I don't have that null terminating character at the end. I can put a maximum of 99 characters plus the extra null terminating character at the end. And then finally, I have my file, the file I've opened up and I'm reading from. So every time I call this function, I will get a new line of text. It will go into this buffer here, a buffer, and you'll notice something weird about fgetS. It returns a pointer, effectively a pointer to a buffer. It provides a pointer to a buffer because we need some way of saying, hey, it didn't work or not. If I try and get one last line of text and that line it does not exist, like I'm at the end of the file, for example, I want this a line start to be equal to null. I want to be able to say something to say like, oh, I'm at the end of my file. That is my workaround. It's this, if this ends up being null, stop. So if that line is equal to null, for every single time I go around this, I'm going to get a new line. If that line is equal to null, not equal to null, so I got a line of text, then I'm going to figure out where the first field is, or the start of my field that I'm currently working on. And we're going to put a breakpoint in here just so I can show you what this actually is going to look like. So this is where my field starts. I'm going to then look for a comma because this is a comma separated value file. I'm delimiting. I am separating the different fields based with a comma. I look for the comma. So I'm keeping around the comma position. And if I have a comma position, then what am I going to do? I'm going to find the next field, which should be immediately after the comma. I am going to then set the character where the comma is. I'm going to essentially stomp out the comma and put in a 0 so that the first field it ends with one of these null terminators at the end. We'll see that in a second. So I'm going to just print out the field, and then I'm going to update what I'm looking at. So instead of pointing at the first field, I'm going to point to this next field. And then I look for a comma again, and I keep on repeating over and over again with this. When I'm finally done, when I get to the end of my line, I won't have any more commas, but when I get to the end of my line, I can let me see here. So I'm at the end of my line. Well, at some point in time, as soon as that comma is no longer there, I'm going to output a field start. Now, field start should already be field start is up here. I might be printing up field start twice. That might be a minor bug in my code, but let's have a look at this. And then when I'm done, I will do this is the end of my while. This is so I have a do while loop to do all of this because I know I have to do it at least once. All right. Now I could have actually just done it as a while loop start to finish, and that would have been fine too. Let's So this is CSV demo. I want to see what happened there. Let's put a breakpoint. Let's find out what happened. So if I go to open this and this file doesn't exist, what would happen? My file is equal to null. There's something going on that I don't have that file anymore. It could be that I don't have access to that file anymore. So let's have a look. this could be that could be the problem here. So, and I may not have right access violation. Let's have one more. Nope, it's missing. So that makes me think, oh, I need to go into this thing here. It's comma separated value file. It's in this particular project that I'm in. It's CSV, all capital CSV dash demo, and the extension should be CSV. There's something weird going on with that. Because the text file was working just fine, but the other one is not. And if I look at it again, my file, oh, yep, if my file is an actual legitimate place. Let's stop it again. See, my gosh, CSV. Let's compile it. Let's have a look. All right, my file. Oh, that my file is now a legitimate place, or if it wasn't before, it is now. So that should work fine. Let's go one step down. I have a total count. I'm going to get a particular line. I'm going to see what fgetS gives me. I want to make sure this is fine. The file's fine. I'm going to read in 99 characters. Okay. My line start. I'm going to have a bunch of gibberish actually. So I'm going to go once around through my loop here, just because I know I have. There's something weird about CSV files from Excel. They put a bunch of gibberish at the very beginning of the file. All right, so here is the new line that I'm dealing with. It is test, comma, example, comma, 2, comma, show, comma, CSV. Okay, so I want to get just the word test, and then I want to move the field to just pointing at the example to show CSV afterwards. So that's what my line of text is. I want to find out where the start of my field is going to be. It's going to point to the field start should be test example to show. I'm also going to look for where my comma is. So I'm going to search inline start for my comma. Okay. So that's where my comma is. It's right here. It's comma example to show CSV. What I would expect. I'm going to check to see if I'm going to go into my while loop if the comma position exists or not. If there's a comma position, if I found the comma, there was a comma to be found, then what I'm going to do is I'm going to get the next position. That's going to be example to show CSV. Not the comma with not the no comma. It's just straight up example to show CSV. The comma position had a comma. The comma position here has a comma at the front. I'm going to stomp on the comma position and put a 0 over there. And now comma position is pointing to essentially an empty string. Also, field start is just the word test because I get to a null pointer, a null character at the end. So despite having this full array, by putting that 0 there, it means I stop what the string that I was dealing with. Okay, so if I print off just that one thing, I will print off the word test. Next, I'm going to move my field start where the next start is. So next start is example to show CSV. I'm playing with pointers to make sure that I'm keeping track of where things are located. Then I'm going to find my comma position again, and that's to show CSV. Great. If the comma position was found, loop around again. The next starts at to show CSV. I'm going to stomp on the value again. I'm going to print off the word start. I'm going to change my field start position to show CSV. And I just keep on doing that over and over for the rest of the line. What I get is this. Test example to show CSV. The same approach works for tab delimited files too. Exclamation points. Notice I get that weird little output with a 0 at the end because of this line here. When I'm out of commas, I'm putting the preceding zeros. The other way, I didn't put any preceding zeros with using this approach. All right, this actually parsed an entire text file, and before we're done, so I instead of using scanf, what I used was fgets. It's going to get an entire line of text, and now I can just do, character string stuff like finding a comma, finding a tab, that sort of thing. But before I'm done, I want to make sure I close my file. So I open my file, I do things with my file. I add, I change characters, I read from the file, and when I'm done with it, I make sure I close it. And that leads us to the next part that I'm going to talk about. Closing the file, it is technically a nicety. So it is, I think it's absolutely critical because if you don't want any kind of weird access violations, closing the files helps you with that. Once your program finishes, it will automatically close the file. But if your program stays open like it's a video game or like it's a server, you can't expect it to close a file afterwards. And you just have access, you would have the right access to that file. No one else could have access to it. And that leads to all sorts of weird things. So, if it's in the code, it's similar to a matter of whether it was included, but it might be a nicety, but it's really a good idea to you get used to it because as the programs go, this is going to get more convoluted and you may not remember to keep on closing your files. So it can be a locked file. So I have access to the file. I'm reading the file. No one else can access it, and that could be a big issue if it's supposed to be some kind of shared file, for example. So just for my sake, if you will, make sure you close your file when you're done with them, just like you have to free memory when you're done with it. All right, so here's another example. Here's me using file close to close a file. Here's me using 15s to put a whole bunch of space in front of the words area. And you can go through each one of these one by one if you wanted to. These are just other illustrated examples of how we could actually use printf, or fprintf in this case. This is fprintf. So I'm writing to the file and I'm calling fprintf. Notice if the file already existed, I wiped it out by this point in time. And then when I finally get done with outputting everything to this file, I call fclose. And this is what my file will actually look like after I'm done with it. So I have 15 spaces in the word area, and then the next line is eclipse, and then a bunch of spaces, and then notice it's a 4.2f, which means whatever my area is, so let's see what the area is. It's pi times major axis times minor axis. Okay. That 4.2 means it's going to be I'm going to have 4 digits, and on top of that, I'm actually surprised that it actually is 4. It should be, I would have thought I would cut it off more than that. And I only have the 83 at the end. I don't have a whole lot of extra precision afterwards because that dot 2 afterwards. So when we're trying to read from a file, we try to read our data, we process, and so if we try to read the data and it succeeds, then we can process the last data that was read. We can parse our text, for example, and then we can try to read more data. That our typical approach is having some kind of while loop to keep on grabbing the next line, the next token, the next field. And so a while loop, and I keep on pulling off things. I just process the data. I call scanf, for example, and I keep on reading the data and then doing something with it. fgets and fscanf return a pointer to the text if they succeed, otherwise null. So the key that you always have to remember is to look for null pointers. When I have a null pointer, I know I have to stop. All right, and to help you process files, fscanf might actually return an integer. I'd have to double check on that one. So fields out. Okay, fscanf, it is an integer. So pointer int. Right. Here is me. Here I am reading a file. Here I've opened up a file. I have a while loop, so I check to see if if the file opens correctly. I then, while there is fields, there are values that I'm printing out. I am going to the total number file, the total number I'm going to output is going to be incremented. I'm going to read in the next thing from the file. Um, fscanf. I should. It seems like I'm missing a particular field because I need the actual field, the actual file I'm going to be outputting to. And then what I will do is I will, if the number of fields that the number of fields I've read is greater than 0, then I'm going to print out some value to the screen, increase my total number. Keep on doing this, and then at the very end, total numbers. This is the total number of things I'm going to read. So I'm going to read 23, 45, 72 to whatever the heck that 24,567, 235, 123, and then I'm going to output that same value one after the other. So I'm reading in from using SCANF, and if I read in something, then I'm going to output it with 5 characters as precision. Notice that it's perfectly aligned here because of this 5, and with whatever number I was dealing with. And at the end, it's going to be, I'm going to have 7 characters. I'm going to output 7 characters, and this particular number is going to be what my total number was. And the total number I've read is 6, but there's 5 characters here because of this right here, or 7 characters, and 7 characters in total. This is one number, so this should be 6 blank spaces and then that number 6. Uh, and if I'm trying to read enough from a file, oftentimes I'll have regular structures, like I just showed you with the CSV file. So it might be something like this: Eric Latte 12, Emily Hot Chocolate 16, whatever the case is. Now, it could be spaces, it could be tabs, it could be new lines, it could be commas. I like to point out that notice that hot chocolate, despite the fact it should be 2 words, had to be put together. Why? Because the English language uses the space all the time. It is a terrible delimiter in a text file. Having one space is not very descriptive because people put spaces everywhere. They put all sorts of extra spaces in places. Having something like a comma or a tab has been considered a useful approach because commas don't often come up that frequently, and tabs never come up. No one puts a tab in their text field very often, or at least I don't think they do very often. So we need something to separate our different fields. I need to put something in between here and here. I need some kind of character or set of characters I can put in there to let people know, okay, I'm at the next field. That's what a delimited file is. So, and we can just have our loop and we can go from field to field to field, pulling off one after the other. So it could be David, and the next field Sprague, and it could be then my student ID or faculty ID, I guess, and it could be my grade for the midterm and my grade for the midterm 2, and then my grade for the final exam and each of my quiz grades. That's the kind of thing we're talking about. If I have all of my grades for a class, maybe they're in a text file. That's actually what the assignment is going to be. It is, I think, comma delimited. Uh, it is all the fields that you have for calculating your grade as, and there's going to be commas in between. And each line would be one type of grade, so quizzes or assignments, that sort of thing. So I'm wondering why I keep on saying A7. It should be A10, but okay. Um, in Excel, oftentimes we'll generate CSV files, and so we'll have things like student name, ID, assignment 1, assignment 2, assignment 3, all the way down. Right? I could put all my grades and my name in a line. I could put every single student in the class in a comma separated value file and then parse everything that way. As long as I have something to distinguish when the next field is and it's consistent, I can do that. That's what a CSV is for. So I go and I find the next comma, then I find the next comma, then I find the next comma. I have every single line has the same number of commas as well, which is important. And allows me to know, Okay, I'm at assignment 2, not assignment 1. Okay. So, this is extremely useful for if I'm trying to parse large amounts of data and I only have it in a text format. Uh, and so they're normally pretty consistent. So what did we do so far? I want to just recap here. We looked at file printing, we've looked at SCANF or FSCANF, and we've looked at how we have comma delimited files and how we delimit it comma with commas or with tabs. When we come back next time, we're going to be looking at code quality, which is going to be our last lecture. I know these are fairly long lectures, but we'll look at code quality and discuss what to do and what not to do when we're writing code. All right, so let's keep our file, and thank you very much for listening, everyone.